Hi, Joe Cerrone. Welcome to CAD 230, Introduction to SolidWorks, in our weekly Zoom classroom meeting. This week, we're releasing Module 5. Module 5 is on object patterns, shells, mirrors, array features. As we take a look at the calendar, October 5th, Module 4 is due at 11:59. I'm not sure why we've got it on here double. I'll have to kind of take a look and see what's going on with that. Typically, they're one per week. And from what I see in the grades, everybody seems to be doing fine with it. But I'll double check with that just so that I don't make a mistake. One of them should probably be, this should probably be 6. And so 6 is for the 19th. But either way, I think I'll just eliminate this one right here, and then we'll be on track. As we take a look at the modules and the exercises, last week's recordings right here. We hold our weekly meetings on Mondays at 6 p.m. Last week, we covered Module 4, which was rib functions and shell features. And then there was this bonus wrench that we can model. And then as we take a look at the content, Module 5, we're working with Chapter 7 of our textbook. And as we go through, here's a video for Lab 5A, another video for 5B, 5C, and then we have 5D in 2 parts. And so the videos are there for your assistance. And then as we go through and we take a look at the other tasks that we have assigned you to do, the multiple choice quiz for Module 5 and the volume quiz, which will ask you the volume of each of the parts. And people seem to be doing just fine with those assignments and getting those turned in. If we take a look at the actual drawings themselves, our assignments for these patterning drawings. And when we look at this first assignment right here, we're creating this linear pattern. And if we take a look at textbook material on Chapter 7, we're making this test tray. And what we'll be doing is creating this linear pattern, sketch command, rectangle, circle. We'll add our smart dimensions, geometric relations, extrusions, shells, linear patterns, and fillets and rounds. It's an ANSI drawing, and we'll use imperial units, decimal, inch place. So as we go through and we create this part, what we'll do is we'll start on the top plane, create this sketch of a rectangle. We'll extrude that, and then we'll create on the top of that sketch face, this circular shape. We'll extrude that. And this is going to be the part that's going to be patterned. So we'll call that the seed. And then once we create that part, we'll create the linear pattern by selecting the vertical edge for the direction and then inputting the number of instances. And then we'll select the other edge for the other pattern. So if we take a look at that drawing, kind of bring it back. Here's our basic shape for that. Remember, you can go through and expand the feature tree, look at the sketches. And so here's our first sketch of that pattern. And then as we go through and we kind of walk our way through how this part was created. And this is one of the things I really like about SolidWorks, is that you can actually see the technique for the design as that was created. And so here's the first seed. And it's basically this circle, which was extruded with a taper. And so as we go and look at it, we can also edit these features by clicking on the feature and saying edit feature. And then we can see that it's a 2-inch extrusion with a 7-degree taper. Check mark that and then look at the rest of the construction. Here's our linear pattern that we created for the part right there. And then once we patterned it, we created a shell for that. And we can again check the linear pattern feature, we can go and we can click on the edit feature and we can see the edges that were selected for direction 1 and direction 2. And then we can see the spacing for those patterns and the number of units for each of those linear patterns. So that's the first exercise. Once we have that patterned, it's always a good idea to round off the corners and to smooth things out. If you don't have a chamfer or a fillet on there, plastic parts have a tendency to break. Metal parts have a tendency to be sharp, and you can get cut on those. Designers typically will add fillets and rounds to the corners. If we take a look at some of the other drawings, it's circular patterns in the spur gear. And on the spur gear, what we'll do is we'll create and again, we're working with inch units, American National Standards. And as we go through and we create these geometries, we'll pick up on a few new commands. I'm not a huge fan of the dynamic mirror command. You can just use a regular mirror. It doesn't save you that much time, but when you dynamic mirror it, it creates them both at the same time. So we start off by creating a sketch on the front plane, and we use a construction line or point of symmetry. We can draw half of it, and then you can either dynamic mirror or just regular mirror it so that it's a symmetrical shape. And then as you go through and create the relations for that, we can add a collinear, which means that this line is even with this line right here. And then we add equal relations for these other angular lines so that they're the same length. And then we can add another center line as our axis to revolve around. And so we create that, and what happens is we'll actually get a hole for that spur gear. And then once we have that round shape created, by revolving it, we'll go and we'll create another axis with the center line. And we'll zoom in on that and create this geometry right here. Again, you want it to be symmetrical, so you can draw half of it and then mirror the other half. And then once we have that, we can convert entities, which is by selecting the edge of the entity, it'll bring it into the current sketch plane. And then will give us the feature or the shape geometry that we want. And what we want is a closed region or shape so that we can extrude cut it. Then once we've extrude cut it, we can use our circular pattern. And then out in the center of the gear so that we can put a shaft through it with a keyway. So if we take a look at that file, here's our geometry all done. And then if we dial it back, not a lot of steps. We have this first revolve that we create the part with. Here's our sketch geometry and our sketch relations. I kind of like mine a little bit neater. I'm not sure. I probably could have cleaned this up a little bit so that the next designer kind of see where everything is at. And so as we go through, we have all of our dimensional information on the sketch, and then all of that into a solid part. Create the geometry for the extrude cut, just like it says in the textbook, where we'll come into this component right here. Draw this sketch pattern. You can see that this part here, there's a line over it, and then it comes down here, goes around. And so we have the geometry for that spur gear cut. And then once we have that, we extrude cut it out of it. And then we circular pattern that, create our gear components. Again, if we want to edit that feature, we can click on it, select edit feature, and then we can see how that feature has been created with the axis direction and the rotation around it 360 degrees. So take a look at your features as you go through and double check those. And then lastly, we want to put in that keyway slot to be able to go through and be able to put a shaft and have it so that it's linked and it actually turns. Back to the next assignment. Circular patterns. This one took a little bit of work, but it's kind of a neat exercise as you go through it. Again, we'll take a look at using circular patterns on this. And so we'll create this. This is another inch drawing ANSI. Most of the same commands that we're using revolve cut, circular pattern, fillets and rounds, revolve. I like to use dynamic mirror if you care to. And so we'll start off with this shape right here on the front plane, and then we'll revolve that. And then we'll go through on the top plane and create the geometry for this leg here. We'll extrude that up to surface to give it this geometry like this. Add the counter bore. Cut it. Circular pattern it. Kind of neat because we create a new plane, and you can do that by either using by holding control and clicking on the top plane and dragging it off and then setting the distance at 1.3. We'll take a look at that when we get to the drawing. And then we create this triangular shaped pocket. Subtract it, cut it, we fillet the whole thing to round it out so it's nice and smooth. We come back into the SolidWorks drawing. Look at that. Dial this back to our revolve command. You can take a look at that sketch. And again, we have videos for these. I'm just going through and kind of recapping the design techniques. And so here we are. Notice everything is fully defined. We can see that it's fully defined right down here. We can see that we're working in inch pounds or imperial units. Go and take this to the next step where we go through and create the leg for it. Again, we create this sketch on the top plane. And once we have that sketch created, fill in it, circular pattern it. Here's our new plane, our top plane. Hover over it, we can see it. If I click on it, I can turn on the visibility. Stays on. And you can do that on the other planes too. So if we want to right click on the top plane and select the eyeball, we can take a look at that. And we can kind of see how that plane was created. As we go through and we look at the plane itself, just like features, you can edit that feature for the plane. And so what we did was we used the top plane as our first reference. And then, like I said, you can control drag a copy of it off. And then you can set the distance at 1.3 inches. And then once you have that second plane created, you can sketch on it and create the other geometry, which is what we do. We go to that new top plane, this sketch right here, right on that plane. And then as we get that geometry created, we extrude cut it, and then build our drawing. That's how the construction for this exercise was created. Lastly, we have this other pattern, and it's a curve-driven pattern. And so as we go through, we create this geometry for the universal bracket. And most people are fine with being able to create the geometry and extrude it. And then you'll notice that this pattern is curve-driven. It goes around all the curves. And so as we go through, we'll learn how to use a curve. The existing file, or you can sketch it. And so at the SDC Publications website, you can go to the SolidWorks Basics and you can download the sketch. We may have it in the drawing, but it's pretty straightforward drawing to create. I recommend you do it yourself. And so we'll extrude this, create the hole, and there's different ways to make holes. They're just using circles right now, but there's a hole wizard that'll go through, and it's better because it uses the tooling to make 118-degree chamfers for like a regular drill, or a 90-degree chamfer for a center drill, so that as we go through and create things, they're created for manufacturing. So as we go through, we create the geometry, we run the curve-driven patterns, we'll use hole wizard. Here's what it looks like for a ANSI inch flathead screw, 1/4 inch diameter. Blind means that the depth is set at 1.25. If we don't set it to blind, it's through wall or another aspect. And when you set them as blind, you actually get the geometry, depending on how far it goes through it, but you'll get the, like I said, 118-degree cone at the bottom for the drill geometry. And then as we go through and we take a look at how that one was created. And if we back this up, the basic shape of the part, we can look at the sketch. It's fully defined. If these relations get in the way, you can turn off the relations right here by saying turn off the sketch relations. Makes it a little easier to see. Back on at a later time. Green check mark. Come down here. Here's our 1/4 inch diameter hole. We edit that, take a look at that. Wasn't used with the hole wizard. And it's just a circle that's been created through that. And I could be wrong on that. Double check and see. And then we go and we apply that to this curve. Curve-driven pattern. Then for the next curve, we're going to do the same thing. We're going to add this 1/4 flathead. And if we take a look at that, one uses hole wizard. Okay, and so as we go through, you dial in the type of hole that you want, whether you want just a counter bored hole or a counter sunk hole or just a straight drilled hole. And then you designate the units of measurement as inches, and then the size. Also get these set up for tolerances and fits so that they're tight or loose fits. And then here's our end condition for that. And then when you position it, you position it on this plane. And so you can go through and add these different positions and then tie those positions down with smart dimensions. After we create that geometry, we'll pattern that on the curve-driven pattern, and that completes this exercise. So those are the exercises for this week for our module 5. And as we continue to go through and work through these exercises. Next week we'll have 6. And then getting ready for a midterm for module 7. And so next week, I'll release the practice exam so that you can take a look at the practice exam and you can practice it. And a lot of the questions will be from the end of the chapters. And so as we start getting prepared for that, we'll go through and we'll create these different geometries for our midterm. It's kind of geared to get you used to how the CSWA exam is set up. They have these really basic, simple parts that you model, and you model a lot of them, and then you apply different materials to them, and you calculate out the mass properties for those. So that'll be coming up. I'll update the dates and things like that, but keep that on your radar that midterm will be coming toward the end of October. All right, that ends our Zoom meeting for today. I'm going to stop the recording and open things up for questions.